Welcome, everyone. Today, we're going to be building a federated GraphQL system from scratch. So this is interactive. Feel free to code along or just watch and ask questions. Let me start by introducing ourselves and the company behind the tools you probably use. I'm Denis. This is Arda. We're from the Guild. We build open source GraphQL tools that powers thousands of applications. We're passionate about federation, gateways, and making GraphQL better for everyone. Before we dive into the workshop, let me mention Jeff's upcoming talk. He'll share what he's learned about schema design, proven schema philosophies, designing the forward compatibility, exposing errors to types, and tips for how to avoid ambiguous and misleading type names. But for now, let's focus on what we're building together. Who here has heard about Hive Gateway? Let me see a raise of hands. Awesome, perfect. Who here has worked with Hive Gateway? Can I see a raise of hands again? Nice. This gives me a good sense of experience levels here in this room. Whether you're new to Hive Gateway or you have been using it, today will be valuable. We're going to build something pretty impressive. For those of you who might not be familiar with Hive Gateway, let me explain what it is first. It's a GraphQL Federation gateway. It's a drop-in replacement for Apple router that uses your existing supergraph. But being JavaScript native means it runs anywhere JavaScript does. It's perfect for serverless. All the features the gateway has to offer are included and open source. No licensing restrictions, no paywalls, free forever. These are the benefits teams discover after implementing Hive Gateway in production. The performance gains are measurable. We're talking real improvements between gateways in the JavaScript world. Smart defaults mean less configuration headaches and faster time to deployment. The ecosystem support means you're not starting from scratch with plugins and integrations, and the operational benefits become clear when you're managing this in production. Version 2 represents major improvements in both developer experience and production capabilities. Some of the listed ones are enhanced OpenTelemetry, means minimal configuration gets you complete distributed tracing. Dynamic log level switching without restarts is huge when you're debugging your production environment at 3 a.m. Event-driven federated subscriptions are new in Hive Gateway and let subscriptions scale horizontally. In-flight request deduplication detects when multiple simultaneous requests target the same subgraph with identical parameters, and instead of making duplicate network calls, the gateway waits for the first request to complete and shares the result with all of the waiting requests. The TypeScript improvements provide better type safety and plugin development experience. Security is now hardened with common GraphQL protections built in, and all of this was built based on feedback from teams running version 1 in production. We'll see some of these features in action today. Let me walk through the building a complete federated system step by step. We start with a basic monorepo using bun, and we'll be building 2 subgraphs. Then we're going to compose it with GraphQL Mesh and set up Hive Gateway. The security section covers multi-layer protection, JWTs for authentication, HMAC for subgraph communication, and field-level authorization with federation directives. We'll also implement common GraphQL attack preventions like query depth limiting and rate limiting. And the safest thing you can do for your gateway, trusted documents, also known as persisted operations or persisted documents. The real-time section adds real-time capabilities with NATS-powered subscriptions that scale horizontally. And we will finish with production-grade observability using dynamic logging and OpenTelemetry tracing. Each step will have a git commit, so all of you can follow or jump to any specific point. By the end of it, you'll have a completely production-ready federated system. For our demo today, we needed to choose a domain that would showcase all of these features effectively. A simple blog platform that everyone would understand. We'll have 2 services, or subgraphs, users and posts. The user service will demonstrate field-level security by placing email address behind an authentication, while the post service will show off role-based authorization and real-time notifications. This domain will serve us great to demonstrate federation, security, and the scalability features. This is a visual overview of the complete architecture we're building. The gateway sits in front of 2 GraphQL Yoga subgraphs. We'll use GraphQL Mesh to compose our subgraph from the individual schemas. Then we're going to use Federation to connect users to posts across service boundaries. Nats will handle our distributed subscriptions for real-time features, and Jaeger will collect traces for everything for a complete overview and enhanced observability. Now that you've seen the overall architecture, let's dive into the security. We'll have 3 layers. JWT will handle authentication, identity, and will carry role information from the client to subgraphs and the gateway. Subgraph directives will enforce permissions at the field level. And finally, HMAC signatures secure the internal communication and will ensure only the gateway can communicate with the subgraph. This diagram shows our complete security architecture with federated directive-based authorization. The gateway validates JWT first to extract user identity and scopes. Then it will check all authentication directives during the planning process. And if any field requires authentication or scopes that the user doesn't have, the gateway will immediately return an authorization error. The subgraphs will never receive an unauthorized request. This protects your backend services from unnecessary load. Only when all authorization checks pass does the gateway make that request to each of the subgraphs. Beyond authorization, we protect against common GraphQL attack vectors. Rate limiting will prevent abuse. Query protection stops malicious queries like deeply nested ones or those that contain a lot of tokens, while field suggestion blocking will prevent schema discovery attacks even when introspection is disabled. Trusted documents represent the ultimate layer of GraphQL API. Instead of accepting arbitrary queries, you pre-register or allowed operations at build time. Clients then send a document hash instead of the full query, which the gateway looks up and execute. This eliminates query injection attacks, schema discovery, and gives you complete control over what you can run. The performance benefits are substantial too. No parsing on validation overhead in production. We'll implement this as a part of our security hardening to show how easy it is to set up. Let's talk subscriptions now. I'll explain GraphQL subscriptions to those who might be new. In traditional sense, a client opens a subscription typically over a WebSocket connection. Then the server maintains the connection and pushes updates when data changes. This works great on paper, but has serious scaling challenges. WebSockets are stateful. Each connection consumes server memory and creates sticky sessions. With thousands of users, you're looking at megabytes of just of connection overhead. Server-sent events have similar problems when dealing with HTTP1. You can't easily distribute these connections across multiple services. In federated structures, gateways connect to subgraphs for subscriptions, therefore putting pressure on both the gateways and the subgraphs. This creates bottlenecks because subgraphs then become a single point of failure for subscription data. You can't easily have multiple distributed gateways because each needs its own connection to the subgraphs. When your server restarts, or when the subgraph restarts or dies for any reason, all clients have to reconnect and therefore can create connection storms. EDFS to the rescue here. Also known as event-driven federated subscriptions. It solves all of the traditional issues we talked about by using message brokers like Nats or Kafka or Redis. Starting version 2, Hive Gateway PubSub has built-in adapters, making setup with any of these message brokers easy. Perfect for real-time features that need to scale to thousands of users. Here's a cool feature. With EDFS, you can emit only the keys of the GraphQL type, and the gateway will resolve the rest of the fields automatically. For example, our post type that we are going to show has an ID key, and you can publish a message to Nats containing only that ID field, but request more fields in the GraphQL subscription query itself. The gateway will intelligently resolve any other fields provided in the GraphQL subscription query, fetching data from appropriate subgraphs as needed to provide the user with the complete response. In practice, it looks something like this. Here you can see multiple gateway instances all connected via Nats, where any service can publish events to the message broker. They don't even have to be subgraphs. All connected clients get real-time updates regardless of which gateway they're connected to. This scales horizontally, unlike traditional WebSocket or server-sent event subscriptions to subgraphs. The beauty of EDFS is that it decouples the subscription source from the subscription consumers. Services can publish events to nets without knowing which gateway or clients are listening. Gateways can scale independently because they are not holding stateful connections to subgraphs. If one gateway goes down, clients can reconnect to another gateway and still receive real-time updates. Same goes for the subgraphs. They can go down without disturbing the gateways or the clients. The message broker handles the distribution, making the whole system fault-tolerant and highly available. Before we talk about logging, let me introduce Hive Logger. It's our modern logging solution designed to run anywhere JavaScript does. No more lock-in to Node or any other JavaScript platform. Built for performance with lazy evaluation of log messages. The key improvement this logger carries to Hive Gateway version 2 is that every log entry automatically gets tagged with context, like the request ID. This means that you can filter your logs by that specific request ID and see the entire journey. Oh, and you can customize the underlying writer, so you can plug in your favorite logging library like Pinot or Winston, or you can output to JSON, or you can simply write to a file. It's all up to you. Now let's see how Hive Logger in action with its most interesting feature for Hive Gateway. You can switch to debug mode without restarting your production gateway. This is absolutely essential for troubleshooting production issues. Imagine it's 3 a.m., something went wrong in production, and you need to enable more verbose logging. Instead of restarting services and potentially making matters worse, you can just change the log level and see everything happen in real time. I'll demo changing log levels in our session. One thing I love about version 2 is how simple observability has become. The OpenTelemetry setup is incredibly easy now. Only a few lines of configuration gets you a completely distributed tracing. Basically, you just have to configure OpenTelemetry itself. Hive Gateway will pick up the rest. Spans are automatically created for all GraphQL operations, allowing you to see the entire request flow of your federation. All right, enough talk. It's time to start building this thing. 3 different ways you can participate based on your preference. You can code together with me, you can watch, or you can just pull the commits as I commit them and run it locally on your system. I will build everything step by step, and as I said, we'll be pushing that code to the repository that you can find behind this QR code. Okay, now I have to just give me a moment to switch up the displays. Can everybody see this? I hope you can.
It's very small here.
Yeah, we'll manage. Okay, so I have a completely empty directory here, and I'm going to start with initializing the project with bun init. We'll just create a completely blank project. I will also remove some of the unnecessary things like the index file, which we don't need. I will also remove the reference to it. Everything else can stay the same. The configuration file is already set up. So I will now push this. So any of you that had checked out the branch here, they can just pull now, and you can get the same setup I have. Another prerequisite is adding prettier, just to make sure that formatting works and that we have clean code to look at. So I'll be adding prettier here, and I will be adding a script that can format everything. So format. All right, let's see whether that works. Looking good. I'll add that as well. Is this too small? I'll increase the size of this one as well. All right, so let's kick this off. Let's create the subgraphs. Since this is a monorepo, all of the subgraphs will be workspaces in it. So first, we will create the subgraphs. Let's start with the users. So users, we'll create a package JSON there. We'll name it users. Then we will create posts subgraph, and we will name it posts. Then we are going to go back to the root package JSON, and we will define the workspaces. We thank you, GitHub. And then we are going to initialize all of that by running install again. Great, now I have connected the workspaces, and let us install necessary packages for running our subgraphs. We are going to install GraphQL. We're going to install Apollo's subgraph package, which will allow us to build subgraph schemas, and we will install GraphQL Yoga to serve those subgraphs. So if we now go back, we will go and create the type defs in the posts, in the users first. So let's create the type defs, GraphQL. GraphQL is always hard to type. Type user, we'll have a key. Let's just use this, and I will remove some of the things and change email. Okay, now we're going to create the server. We're going to import a bunch of code, so we need things from Apollo Subgraph, the build subgraph schema. Then we are going to import the server. We will also be importing a parser from GraphQL to read those type definitions, and then create Yoga. Copilot. Yeah. And then we are going to import the type definitions using the handy with syntax. This will allow us to type text. This will allow us to auto-reload the services using Bun's watch mode without having to restart anything. And I'm just going to make TypeScript happy. So now I'm going to create some users. We will store everything in memory for now because we don't really need to expose a database. It's just an example. So let's add an email. We'll have this user be 0U1. Let's add Bob. Let's add Charlie. I think that's enough for now. Then we are going to build the actual schema. So let's set the schema up. We will pass the type defs. Like this. We will pass the type defs that are parsed. And then we will provide the resolvers, the user type, and we're only going to resolve the reference of the user like this. And I have some syntax. Oh yeah, semicolon. There it is. You know when formatting works that your code is free of syntax errors. So we now create a Yoga instance, and we will supply that schema to Yoga. And then using Bun, we will simply serve using port 401 serve, and we will pass Yoga as the fetch handler. And we're just going to console log, making sure that it works. So now if we go here, and then if we go to subgraphs and users and do bun run server, the server should be running. That's great. Let's add one more improvement, and it is a start script. Start. It will watch the server so that if we make any changes to the server itself or any of the imported packages files, it will automatically restart. So now if we go and do bun start, we go back and change the logs, for example, like this, we see that the service has automatically restarted. Okay, let's go to posts, and we will do the same thing in posts. So there I will create a type defs file, GraphQL. I'm just going to copy this. Oh yeah, so here I have a query that will fetch all of the posts. I have a post containing a title and content, and it will contain a user, but the users in the post service will only have an ID, meaning that the rest of the fields have to be fetched from the user service. So now I'm going to set up the package JSON. I'll just copy this one here and rename the name to posts. So we have the handy start script running here. Let's set the server up. I'll make a copy like this. We'll remove the users. We'll set up posts, and then we have posts already working. I'll just have Copilot autocomplete some things, and then we will change the structure to match our type definitions. So this is looking good. Now we are going to change the post resolver, and we are going to resolve from posts. I'll make this change as well, and we are going to add the query that will simply give us all the posts. All right. Here on the bottom, I will change the port. I'll say starting posts, and here I'll change the port as well. So this is looking good. Now, in the root package, I will add yet another handy script called subgraphs, like this, which will look at the workspaces and take all of the packages in the subgraphs directory and run the start script on them. So if we want to take a look at that in action, and we run subgraphs, we see that both of the services are ran at the same time. Good. Let's commit this. So we have subgraphs, and I'll push this live. Any questions until this point? Awesome. It's pretty clear. OK, so now we have the subgraphs running and the services available. We need to compose the supergraph. For that, we are going to use GraphQL Mesh. So let's install it first. GraphQL Mesh Compose CLI. Yeah. Then I'm going to add the mesh config ts file. Oops. And here I'm going to import the necessary things to define the config and to load the GraphQL subgraphs. Then I'm going to create a configuration and export it like this, providing the subgraphs exactly. The first one being having the source handler loading that subgraph that has named users. It will have an endpoint here, and the sources of the type definitions are in subgraphs, users, type defs, GraphQL. This is looking good. I'm going to copy over this one and do the same for posts, and I'll change the port. So now we have the configuration ready. Let's add the compose script to our package JSON. Thank you, Copilot. And we are going to compose. Awesome, it worked. We didn't have to have the services running because we are providing the sources directly to Mesh. All right, one final thing I'm going to do is create a prettier ignore file because I don't want that supergraph to be formatted. This is looking fine. I'll run compose again. Compose. And I will commit this. Awesome. So now we have the supergraph ready, and the final step at this stage is to run the gateway. So we will add the gateway. And then in package JSON, we are going to add a start script that will run Hive Gateway in supergraph mode. It will automatically pick up the supergraph that we have in the directory that the gateway is running from, and it will serve that supergraph. So let's start it. Great. Now, if we open a new window and we go to localhost, we see the Hive Gateway is running. and let's try to execute some queries. So title, and then I will fetch the author, and I will get the author name. I will remove the headers. We don't need them yet. Perfect. Do you know why? Well, I didn't start the services, so let's run the subgraphs. And then in a new window, I will start the gateway. Let's try that one again. Perfect. We are getting the results resolved from all of those subgraphs. Now, let me commit this. Okay, so now we have a system running that is serving Supergraph and is looking up all of the subgraphs and fetching data from them. Let's start with our first security improvement. We are going to add JWT authentication. So let's first create a shared environment for all of our services. I'll be just using TypeScript because we are using bun and everything can work. Secret, and we'll make a super secure secret. Then I will go to the gateway config. I will create one. Gateway config TS. This is the config that's read by Hive Gateway. Define config. And I'm going to define. Great. I'm going to use JWT, and as the signing key provider, I will use the inline signing provider exported from the gateway itself, and to it, I will be passing the JWT secret from the env file. So that is looking good. The gateway should, I will add one more improvement here. I will change how the gateway starts. So I will run the gateway in Bun's watch mode so that we can get automatic restarts while we are working on the code. So if we go back, we have to restart the gateway once. It should already have the JWT authentication enabled. And now if we try to query, it will say unauthenticated. Just for convenience reasons, I will be creating a small utility that will help us generate JWT tokens. So let's first add JSON web token, like this. And then I will create a file called jwt.ts. I'm going to import JWT, this. I'm going to import the secret. I'll have a payload that'll be empty for now. And then I will generate the token. We don't need this parameter. And I'll console log it. One improvement that I'll make is I'll already have it be in the headers format, authorization like this, so that we can conveniently pass it back to GraphQL and just have it work. So let's start with bun. We have a header like this. We will put it in the headers area. And if we execute the query again, we have it working. It's great. Next step is to commit all this and push it. I hope you all are following along. And if you have any questions, please feel free to stop me and ask them. All right, so let's go back here. We will now add a different security layer, which is HMAC, that will allow us to sign our messages, requests actually, going from the gateway to the subgraph. And the subgraph will evaluate and validate those messages, making sure that they are coming from the gateway itself. First, we need to create another super secret for HMAC, which will be 456. That's very secure. And then we are going to go to the users server. And here, in Yoga itself, I will add a plugin. Use HMAC signature validation. And there, I will provide the secret that I have just created, like this. Plugins. All of these have been automatically imported. So we have HMAC secret from the .env file, and then we have the signature validation from the gateway file. I'll do the same thing with posts in user. So I'll add the plugins with this. And I'll make sure the imports work. They're all here. Since we have started the subgraphs also using bun watch mode, they will be automatically restarted as we go, so we don't have to do anything there again. So now if we try querying, we will see unexpected errors. And those errors are coming from the subgraph that are communicating to us that the HMAC signature is not found in the request. It's intentionally an internal server error because it's a setup issue. You should not be exposing your internals to the user land. So now let's add the HMAC signature signing to the gateway itself. So we can go back here. We just add the property and give it a secret. HMAC secret. Perfect. The gateway should have restarted itself as well. And if we try to query again, we see that all of the queries are passing through. Perfect. Let's commit all this. HMAC. Now we are going to add authorization by using the federation directives. Let's start with @authenticated. Let's go to users and the type defs there. First, we have to upgrade the federation to use the latest one, and then we are going to import the @authenticated directive, and we are going to protect only the email here. Then we have to compose again, run our handy bun compose. The gateway itself is listening and watching the changes of the supergraph, so it will automatically reload it as it sees it changing. So we don't have to restart the gateway yet again. So now that we have this enabled, we will go to the gateway. We'll go to the gateway config, and we are going to enable generic auth with the mode protect granular, meaning that it will be reading the directives of each of the subgraphs and making sure that all of the fields get protected. So another thing that we have to provide is the user. So the resolve user function actually gives you the context, and from the context you have to provide the user back to the generic auth. This user will be forwarded and evaluated in the gateway, as well as forwarded to the subgraphs if need be. One thing we noticed is that the JWT is not typed. So to fix that, we have to add context extensions when we define config. So here inside the generic of define config, we are going to add the auth context extension. So now if we take a look, if we check the JWT, we see that it has these fields, one of them already being payload. So that's looking good. So everything should have been restarted. And if we remove the headers and try to execute, we will get unauthenticated. But we want to only protect the email field. So to make sure that the requests still go through, we want to make sure that we are not rejecting missing tokens. This will make sure that the requests that you're making, even if they don't have the token available, they will be forwarded and executed on the subgraphs using the generic auth mode, meaning it will detect the directives used and behave accordingly. So now if we try executing, it will work. But if we try to query the email field, it will fail. And the whole thing failed. Maybe we didn't want to fail the whole data, and we wanted to only omit the email field. There's a way to do that as well. Here in the generic auth, we can say reject unauthenticated false. Now if we try, we will get all of the fields except for the email. The email will be empty, and you'll get an errors field saying that all of these emails have been omitted because you are not authorized. Now, if we go back and we provide a JWT token like this, we see that the email is being provided and no errors are thrown. Perfect. Let us commit this one as well. Oh, my bad. Let's use another directive. This time we are going to use the @requires_scope directive. So let's go to the posts, type definitions, and here we have to do the same thing. On the top, we have to import and use the latest version 2.7 of Federation, and we are going to import the requires_scope directive. This indicates to the gateway that in order to execute this field, the mutation create post, you have to have the editor scope provided in your JWT token. Let us compose this. Perfect. The gateway should have been reloaded. And let's us try using that mutation. Create post. I'm going to ask for the ID. And again, even though I have the JWT provided, I'm still getting an authorization error. Why? Because if we go and take a look at the genJWT function, there are no scopes defined in our payload here. So we need to add the scope. So let's say, let's add the scope. This is an editor. And we are going to generate a new token. This token will have the editor already available inside. And now we get an internal server error. And that is simply because the resolver for create post has not been implemented. But the gateway requested that from the subgraphs, and it failed, as you can see here, because the subgraph itself does not have the resolver implemented. All right, so let's implement that in the resolver. We will go to the servers post. Here we are going to add a mutation. We're going to add post. And then this is our new post with the author. But we want to use the author from the JWT token. We don't want to just add some arbitrary authors. So there is multiple ways we can approach this. The first one I'm going to show is the functionality to forward the JWT token from the gateway to the subgraph. The gateway itself will make sure it's valid and make sure to parse it correctly. And then inside the request itself, it's going to add the parsed JWT fields as extensions. So first we need to add another plugin called use forwarded JWT. It's also imported from the Hive Gateway itself. And back to the gateway, we have to say here in the JWT that we want to forward the payload. Hopefully everything passed. And then back to the server, and then here, the author ID, we first have to import the context. The author ID will be context. It's the same usage as you would use it inside the gateway itself. You will basically use the JWT payload sub. That's the convention in JFT payloads where you put the user ID inside the sub. Now, if we try to execute, it will fail yet again because there is no sub defined. So now what we have to do is go back to our genJWT and add a sub. We'll say user2. Let's try that one again. Failing. Because I didn't generate a new token. And again, failing. I didn't return that new user. No, new post. And of course, I'm going to push the post inside the array that we have here. Let's try that one again, and it worked. So now if we query all of the posts, we see that the new post that we had just created is added, and it's been assigned to Bob, which is the U2 user that we had set up inside the JWT gateway itself. So that works. Let me commit that to you guys. However, this means that your subgraphs need to understand that the form of authentication used by the gateway are the JWTs. Maybe you don't want to put that burden on your team, your subgraph team, and instead you want to move all of the logic back to the gateway itself and have the gateway provide the subgraphs with an already resolved user ID. The way we can do that is by propagating headers. So if we go back to the gateway and we implement propagate headers from clients to subgraphs. And then let me make it more convenient. And then we pass a header called X user ID that contains will contain the payload sub inside of it. And the requests that go out to the subgraph will contain this header, but I'm going to disable forwarding the payload. And I'm also going to remove the use forward JWT from our usage in each of the gateways. And instead, I'm going to use the request headers X user ID. And I'll make sure it exists, otherwise fail. Now, everything should have restarted on its own. If I execute the mutation again, I check the ID and I check the resolved user and its ID. We see that yet again, we are resolving the new user tool, but this time by pulling it from the headers itself, and we have removed all of the burden of the subgraph needing to understand what our authentication principles are in the gateway. I'm going to commit this and push. All right. So the system is pretty secure now, but we want to add more security to prevent potential abuse and attacks. Common attacks on GraphQL endpoints contain constructing malicious queries. Queries with nested depths or crazy long messages, a lot of tokens, infinite recursiveness, and things like that. In order to showcase how someone can make a recursively nested query, we first have to adjust our subgraph's type definitions by adding some commonly happening recursiveness into the subgraph. So we are going to first go to users type definitions, and we are going to add liked posts to the user. Post. And then we are going to add a post like this. But the user service only knows about the ID of the post. It does not know the name. The name and the content will have to be resolved elsewhere. Now, inside the server of users, we will have to change the users and add some liked posts. Now we see that Alice liked P1, Bob liked P2, Charlie didn't like anything, but this will allow us to construct a query that can be nested many, many times. That's composed, okay. So the first thing I have to do is compose, and that's it. So now if we go back, we reload to get the new introspection running. So we can request posts, and then we can request the author, and then we can request its liked posts and the author of them, and their liked posts and the author, and then you can keep repeating this many times over. And you can imagine that this is okay, but if you repeat this many more times, and if you have a lot of posts as well as a lot of liked posts, not only does the query become recursive and dangerously DDoSing your subgraph services themselves, but you can also construct a response that is huge, both for the gateway and for the client to consume. To prevent this, the gateway now has max depth limitations. So if we provide a max depth property and we say the maximum recursiveness depth is 5, we should not be able to execute this query because we have created a query depth of 8. And this way we are protecting the execution of recursive queries and dangerously attacking or DDoSing our subgraph services. Another potential attack is completely valid, but you can request many times the content, like this. And you can, this is completely valid, even though it's duplicated, it's completely valid GraphQL, but you can create queries that have a lot of tokens, tokens being post is a token, the parenthesis is a token, content is a token, and every single one of them. To prevent such queries, you can just limit the tokens, like this. And now if we try to run, it will fail. But our introspection will also fail. So I will increase this max token limit so that we have introspection back. All right, another thing you might do is to disable introspection. And I want to disable this introspection at all costs. So the disable if function is a function that executes an introspection request and lets you decide whether you want to disable the introspection or not. So if we go again, if you go back and remove, and refresh, we will see a bunch of errors, and these errors are basically telling you that GraphQL introspection has been disabled. You can, of course, make it so that you allow introspection to users that are authenticated. So disable if, only if there is no JWT payload, meaning the JWT is missing. Now if we refresh, we see that the introspection had worked again, and we are getting all of the queries already here. However, if you end up exposing your introspection and you want to keep it disabled, or you want to keep it disabled only for outside world, there is another trick that people use in order to figure out what your subgraph, what your schema is without actually performing introspection. And it's a sophisticated attack like clairvoyance GraphQL, where it figures out your GraphQL schema without ever making an introspection request. So if you Google clairvoyance GraphQL, there is a repository that basically has a utility you can download and execute it on endpoint. And what it does is it will try and execute with a word list all of the wrong fields, and it will detect what the suggestions are. So here at this place, we are requesting a posts content A, which does not exist in our schema, but GraphQL is helping us figure out what we wanted by giving us a suggestion. Did you maybe want to request content? So now if you construct a big query that will give you a lot of these suggestions, you might end up having your query, your schema introspected without even knowing. To block that, we use yet another feature, which is called block field suggestions. And this will basically hide all of those suggestions, making you even more secure. Okay, great. So I'm going to commit this. Okay, we got some attacks covered, but we still don't protect against abuse. People can still try and send a lot of queries to overwhelm the gateway, the subgraphs, or just to populate our database with gibberish data. For example, you can spam the create post mutation, and you can create a lot of posts real fast. Let's protect that field by rate limiting it. So if we go to posts, and we add import the guilds, sorry, can't type. The guild dev GraphQL mesh spec version 1.0, we can import the rate limit directive. And here we have to compose that directive with federation so that it's valid. We can then define it, directive rate limit. It's only available on fields, and it also has a message telling you what went wrong. So now with this directive, we can say, okay, I want to protect the create post mutation and make sure that only 5 posts can be created within 1 minute. Otherwise, we will be raising an error to the user and complaining that they are trying too much. So if we compose again, stuff should have been restarted already. And let's try abusing the create post. Oh yeah, I forgot one important thing, and that is enable rate limiting in the gateway. This will read all of the rate limiting directives and make sure that the gateway rate limits everything that's nasty. So content, again, like this. And the first few will work, but then suddenly you will get rate limited. This will stop potential attackers or users that are completely valid in your system from abusing your databases, your subgraphs, and your gateway.
There's a question.
Sorry.
What does it use to actually figure out if it's the same user?
It's the same user? Yes. So for rate limiting, you can add configuration options. Right, Arda?
Yes.
And you can provide an identifier.
Yes.
Like this. We're getting some errors. It's because
Yeah, we need to extend the.
yeah, the types are wrong here. But basically, you can configure an identifier that will make sure that this matching the rate limiting to either the authenticated user or the provided IP or globally to everybody. The defaults are globally to everybody. So it does not matter who is making such requests. They would be globally disabled. So let's put all this back.
Another question as well. So is there a way to configure how long are you rate limited and how we calculate it? Like, can I do exponential backoff? And if you're trying to DDoS me first, like, if it's a valid user,
Yep.
they can wait a minute, right?
Yep.
If it's a malicious user, I would probably block it.
Yes, so using the configuration I just showed, you can make your own option, but not with directives, because the directives would be overly complex. You can create a configuration like the one with identifier, where you can pass your own rate limiting function that decides which, how long the users get rate limited.
It will also log the information about the request, so you can follow the request ID and block the user.
Okay, let's just compose once more, and I will be committing this. However, the best way to protect yourself is using trusted documents, also known as persisted documents or operations. So let's set that up real quick. I will close everything. And instead of, since we don't have a front end and we don't have any sources of queries, we are going to construct our own store of the queries that are whitelisted inside a super simple doc.json file. So here we say that only the query named Q1 can execute, and this query will be executed when provided. To set that up in the gateway, you want to enable persisted documents, and you want to get the persisted operation by key. And I'm going to import the docs using bun. Parse it to JSON. I'll make the function async here. Yes, and then I will return the operation from that doc.json file. So now if we try to introspect or to run any query, we are basically stopped because the persisted queries can only be run. One common thing that you would do with persisted documents is disable GraphQL, the IDE for your gateway. This way because it simply does not make sense. You cannot create and issue arbitrary requests, so you can go and just disable it like this. So now if I refresh, it will just not work. But if I make a request to the GraphQL endpoint and pass in the document ID Q1, okay, I get an error. There's no docs.json? Doc.json. My fault. I'll rename this one better. Okay. And we try again. We see that the query did go through, but the whitelist has to already exist. Just for the sake of the remaining examples in this workshop, I will be re-enabling GraphQL, and I will enable arbitrary documents so that we can execute our queries and continue with the examples. So let's confirm this works. Yes, it does. Okay, enough about security. Let's talk about subscriptions. Let's use EDFS, or event-driven federated subscriptions, to distribute and to publish events of our schema. So let's start by creating nats and enabling it as a service. So we are going to create a compose file. We're going to define nats. We're going to use the nats image, and we're going to expose its port. The 4222 port is the default nats port. Now we go back, and I will simply Docker compose up, have nats running. Then I will have to use the pub/sub using nats inside our gateway. But before that, we will have to install the nats IO official transport for Node, which also works with bun, so we will not have any issues with it. Let's go back here to our gateway config, and inside pub/sub, I'm going to create new nats pub/sub. The nats pub/sub is already readily available from the gateway itself. And I'm going to connect to the nats service on localhost. And I'm going to import connect from the just installed transport package. Then finally, I'm going to define this, the subject prefix, just gateway, which will make sure that all of the events emitted to this nats pub/sub and also all of the events subscribed will have this prefix prepended to the subject, making sure that you are not accidentally publishing, if you're using nats for something else, making sure that you're not accidentally publishing events to everywhere, but you want to focus to the gateway itself. Okay, great. So now we want to create subscriptions. We need to define the subscription type. Let's go to posts, because we will be defining a subscription field there. Let's make one, subscription, posts created, and it will emit a post. One handy directive that we have is pub/sub operation. We have to compose it as well. And add the definition. We only need to define the pub/sub topic, which is a string. And then we will provide this to the pub/sub subscription field with the pub/sub topic post added. This will indicate after composition to Hive Gateway that when faced with this request, it will not make a subscription request to the subgraph. Instead, it will subscribe to the pub/sub, and it will use this topic to subscribe to, of course, with the gateway prefix, subject prefix that we added. Great. Let's compose. And finally, we have to emit the data. So if we go back to posts, to our posts server, we can use the same exact net, the pub/sub, sorry. New nets, pub/sub. We will connect the same way we did with the gateway, and we have to use the same prefix that we used as in the gateway. Doing this by having the exact same pub/sub on both sides, you basically connected them. So everything that you publish here in this service, wherever it's running, it doesn't even have to be a subgraph, it can be a separate service. Whatever you publish here will also be available in the gateway itself. So let's use it. But before we start, we will make some type definitions. So post added requires an ID, only an ID. Oops. Where am I at here? Okay. So now if we take the pub/sub and we go to our mutation, after pushing to the posts, we are going to publish it. Pub/sub, publish, post added with that new post ID. Notice that I only provided the ID, and this ID will be used by the gateway to intelligently resolve all of the remaining fields that you might have requested. Just to make sure, I'll do one more compose. And then, in one window, I'm going to prepare a mutation. I'm going to, yet again, create a hello world. Let's see its ID, its title, its content. And here, I'm going to subscribe to post created. And I want to see the content. I want to see the title. I want to see the author. I want to see the like pose of that author, etc. So now, I'm subscribed, and I will be creating a new post. And we get an error. Okay, let's see what happened. Let's try slimming it down.
We might have broken something.
Yeah, we might have broken something while preparing. Okay, it works. So let's subscribe again and create a few new posts. You see that every single post we got rate limited, but all of the posts have been published to the subscription. All right, great. So that is working. There is another handy directive that we added, which basically will allow you to publish posts without doing all this inside your subgraph. We called it pub/sub publish. And if we go to posts and its type definitions, and we included inside mesh, and we, of course, compose it. It has the same interface like the operation, but this time we are going to put the pub/sub publish on the mutation. This will tell the gateway that every time somebody issues this mutation, it should subtopic. Thank you, Arda. This will tell the gateway that every time we issue a request with the create post mutation, the result of that create post will be published to the pub/sub of the gateway. So all of the heavy lifting will be done by the gateway. But in case you have multiple distributed gateways, all of them subscribing to the same pub/sub, one gateway will publish to every single one in your distributed system. We also can confirm that by going back to the posts service and removing the pub/sub from there, because we pretty much don't need it. Okay, this is looking good. Let's run compose again. I'll restart the gateway just to refreshen up the rate limiting. Again, I'm going to subscribe, create a new post, and see the post already available inside the gateway. All of this had happened automatically inside the gateway. To confirm that the pub/sub is working across your distributed system without any changes to the existing setup, I'm going to create another gateway with a different port. I'll put this one on 5001, so we have 2 gateways now. All right. Both of them will subscribe here, and I will create a new post. And the first gateway on port 5001 had received the event, as well as the gateway from 4000. So you can basically horizontally scale your gateways and make sure that you use the same pub/sub, and all of them will be receiving the same events from the shared subscription topic. I will commit this. EDFS. Okay, so we have shown how event-driven federated subscriptions work. Let's show off something interesting. We will be seeing how dynamic log level changing works. There's many ways for you to change a log level on a running system. You can either subscribe using the pub/sub, you can send a process signal, you can have a protected HTTP endpoint, many ways. But I'm going to show something very simple and very secure. So I'm going to create a plugin. Very simple. It's a gateway plugin. And I'm going to have an on-request hook that will take the request. Oops. And if the request URL ends with toggle debug, we will change the log level. So we are picking up the logger from the plugins because this is the rootmost logger. This logger will basically be used to create child loggers that contain metadata about their flow. And if we change the root logger's log level, it will reflect on all of the child loggers as well. So let's change it. We say go to the log. We set the log level. If it's debug, we set it to info, or if it's info or anything else, we will be setting it to debug. And then I'm going to just toggle log level to this. And I'm going to return, and I'm going to end the response with the new response. So this will indicate to the caller that the log level has been toggled. I was joking when I said that it's very secure because anybody can call this, but feel free to secure it however you want or use any system to toggle the debug level inside your gateway. So if we go back, the gateway should have restarted already. If we clean up the logs in the gateway like this, and I'll just execute posts with the title and the author name. Make a request, the post work, but we don't see any logs because those logs are debug logs that will tell you all about the process of solving the query planning problem and making requests to give the user the response. So if we now go back to the gateway and we toggle debug, we have toggled it. And if I run again, we see here that the log level switched to debug. And if I now run again, we get the response, but we get much more verbosity inside our logs. As you can see, the request ID is appended to every single step that's been made, so you can use your log consumer to filter and get everything you need. And if we toggle the logging again, it's now back to info, and I make another request, we will see that no other logs have been made because we have reverted the log level back to info. The beauty of this is that the gateway will remove and unmount all of the plugins and code that actually inspects the debug process of the query planning. So if you had reverted back to info, all of the performance bottlenecks that you might have when using the debug log level will be again removed, and your gateway will be as the same as when you started. You won't be having any issues with parsing the internals to produce a more verbose log. I will commit this, so log level change. Okay, we've come a long way. It's time to get some insights on what's actually happening in the gateway. We want to see it resolving queries, how long things take. We want to see which subgraphs have been called. And of course, we want to see which queries errored out or if there were any issues in the process. And the best tool for that would be OpenTelemetry. Before we begin, we have to prepare a service that will consume the OpenTelemetry logs, traces. For that thing, we will use Jaeger, which is the open source distributed tracing platform. Let's create and start a local service running Jaeger. I'll just add it here to the compose file. I'll just copy this. Yeah, too much to type. All right, so we're now using the official, this is the official image from Jaeger Tracing, the latest version of it, and we will be exposing the app ports and the tracing over HTTP, but notice that we are binding the tracing to a different port because I have something running there. Save that, we go back, I'll restart and Docker compose up again, and now I will go to, I'll just clean this up, I will go to Jaeger, and I will see that it's all working. But we don't have any services, we don't have any traces yet. Now we have to set up Gateway to report to this service. Okay, we go back and we will install some OpenTelemetry things that we need in order to create proper tracing. We will be using the async context binding tools from them, as well as a regular HTTP exporter. Now, if we go back to the gateway config, I will simply set up OpenTelemetry. OpenTelemetry setup is our handy function that will, from the gateway, that will set up the OpenTelemetry properly in the environment, and will make sure that both the official OpenTelemetry SDK as well as Hive Gateway is using it as designed. So for the context manager, we are going to use the async local storage context manager. And for traces, I'm going to export them to URL to our Jaeger instance running. We will also add some information about our resources. The service name, I'll just name it Gateway. And the service version, I'll just give it version 1. And the final thing is to enable OpenTelemetry inside the gateway. We'll just say report traces. And that's it. This should work. Let's see, the gateway has loaded. We also have logs confirming that OpenTelemetry integration is enabled and the exporter has been registered. So now I'm going to make a more interesting query, just to showcase more tracing points. Okay, we're going to execute this. And it's here. We have the gateway service available. And if we check the traces, we have just the introspection query, the initialization, sorry, and we have this request that has just been made. And if we click on it, we will see each of the steps and how long they took. We will also see attributes, tags, information about each of the queries that have been made in thorough detail. All of the subgraphs that have been fetched and the request options parameters that have been sent to them. That was very easy. But maybe you want to add custom attributes to these OpenTelemetry traces. Maybe you want to track the authenticated user ID. That's also simple. So how would you approach solving that is simply by, let's say, we are already resolving the user inside here. So why not just reuse this part and set the attributes of the trace to the payload user. So we're going to put this user like this. I'm going to get the active span. And this trace utility also comes from our gateway's OpenTelemetry built-in integration. And this will allow you to get the currently running active span anywhere in the gateway. And I'm going to finally set the attribute to the user ID. And I'm going to return the user because I want this function to resolve to a user. Let's make another request. Now, if we go back and refresh Jaeger, we have another request that came in. And inside the context, we see that the user is available there. So you have the information of that user in your traces. However, this seems quite deep, so it's not where you would expect it. You might want to have that user already in the request itself, but not deeply nested inside the context. In order to change that, you can simply get the HTTP context of OpenTelemetry. To do that, you import the Hive utility, which is our Hive's instance of OpenTelemetry running. And you want to get the HTTP context of the request. So we have the incoming request inside the context of the gateway here. And providing that request to this function, it will give you the OpenTelemetry context bound to this request. So let's get that one. And instead of getting the active span, you would want to get the span that has this OTel context. I'll just force TypeScript to compile. All right, looking good. Now, if we run the same query, and if we go back and find traces again, on the top, you will see that here, this time around, the user ID is available at the rootmost operation, the request that has been made. OK, great. We covered everything, but our time is running low, so I want to quickly showcase our new upcoming feature in Hive Console, which is tracing, meaning that you can use tracing in Hive Console without Jaeger, without any other service, but directly report there. So I have Hive Console running, self-served on an EC2 instance. And I have a project running. And I will first show you guys, if I run out of time, how it looks. So this is the new tracing tab that will be available in the upcoming days and months. And you can, the same way you would use Jaeger, you can see all of the requests being made. And if you click on one of them, you get the full trace, full span of every single part and how long it took. And you can, of course, have the resort attributes available, like the version you're running, and also the user ID that you would have otherwise provided. OK, let's try making it work in 10 minutes. So the first thing we need to do is I will create a brand new, I will delete this project, because I like the name. I'll create a new project. It's a federation project called Proj. Then I will create an access token. I'll create a new one, test2. And this one will be able to publish subgraph schemas to the service. It will be able to create app deployments for something that I might not have time to show. It will be able to report OpenTelemetry metrics and user data. Great. We have the token. I will create hive.json file that is that will be used by the Hive Console CLI. And we will, oops. We will paste the token here. And we have to provide the endpoint, which is this one. The GraphQL endpoint is on 8082 GraphQL. This is where it will be reporting. Then we go back and we will install the CLI. And I will publish first the user's subgraph. And then I will do the same for the post subgraph. Both are now published. And if we check online, I stored it, thank you. We see that both of the services have been published, and we have a supergraph containing the same thing that we have built locally, because Hive Console is helpful and will do the composition for you. So now back to the gateway. We want to enable tracing, and we will do that simply by Hive tracing setup. We will replace the OpenTelemetry setup with Hive tracing setup. We will remove all of this, but keep the context manager because we need it. I will supply the target, which is GraphQL Conf 2025. I will give it the access token from that JSON file. I don't need this. And I will provide a different endpoint from the default one because we are self-hosting Hive. So let's pick this up, put it here. It's 4318 v1 traces. OK.
There's S.
Traces. Thank you. This had hopefully automatically restarted. And now if I make a query and go to Traces tab in Hive Console, I hope I'll see them. I didn't provide an access token, did I? I did? Batching. Logs. Toggle debug. Let's make more queries. OK. Tracing is not showing up. What did I miss? I hope I opened the port. It did.
It works on our local.
It works on my machine. All right. Let me try this again. Maybe I just have to restart the gateway.
Probably it flashes when you restart.
OK. It literally worked 20 minutes ago. OK, here it is. Yay. So batching took a while. We're having the full traces available already in Hive Console, like you would see them in Jaeger. So we have the same information. Let's take a look at the operation. It contains the user ID, like the one you would see in Jaeger. And it contains as well as the full information of which requests have been made, where and when, and how long each of the requests have taken. Thank you. I would be showing you much more about Hive Console, but sadly, I'm running out of time, and I want to leave area for questions if there are any. Thank you. Thank you. No questions? Where's my presentation? Okay, so let me switch this off. This is the workshop summary. So we created subgraphs. We set up the Hive Gateway with what? Oh, yeah. Hive Gateway configuration for other languages. What do you mean? Like not use JavaScript for the config file? No. So the gateway is a JavaScript program, and it runs only the JavaScript configuration. Any other questions before I turn around? Yes, Sahaj? I'll let you answer, yes.
Yes. We can. Let's open it.
Yes? Can you just speak a bit louder? Sorry, I didn't hear you.
So what kind of resiliency patterns do you have on the gateway to all of like your other, let's say Yoga will split up into multiple services? How would the gateway handle resiliency on that area?
Resilience to, sorry, for another time, I didn't hear you really well.
It's a gateway to use Yoga, as an example.
Okay.
So you've got another Yoga service. The gateway couldn't communicate with the service because the network is
Okay.
got issues. How would you retry that request?
A retrying request in place can happen with the retry request. So the gateway will intelligently, when configured, retry requests before failing it for the user request on the other side.
So it's one retry.
Yeah, it will retry, yes, when configured. Yes. Yes, so for caching, we recommend using Stellate, of course, but for subgraph caching, we have some built-in functions that will allow response caching when HTTP semantic response caching for apps, which sadly I couldn't showcase because I need a full browser and an app that will make those requests and have them cached. But if you want to cache on operation level or even partial query caching, I would recommend using Stellate, where you would just plug in the URL of your gateway, and it would just work. I wanted to showcase that too, but my typing skills didn't allow it. In the gateway, you can invalidate, you can decide when to invalidate. You can invalidate on mutations, or you can have a function that decides when and what you want to, I mean, not what, but when to invalidate everything. But mostly, by default, it would be using TTL when set up. We also have directives like pub/sub operation and pub/sub publish. Rate limit, we have directives for the HTTP caching, so you can decide that on subgraph level as well. Yes? Request batching for subgraphs?
We are doing it automatically. So we are batching the requests down to the subgraph, and so they are merged into one single operation, then send the subgraph. So we are doing it internally, but you can control it with extra flags, like if you want to avoid, like extra load, or, I mean, in that case, like the query becomes larger. So if you want to avoid that, you can configure batching. There are flags. We have like batch delegation flag for that. You can check the documentation for that.
Yes. You can also configure the size of batching. So
Yes.
to avoid having too much of requests, you can say, I only want to batch n amount of queries inside one, and then we will create separate requests with the batch limit.
It's infinite.
So I wanted to show how the subgraphs can be published to Hive console, and it will do the composition and pull the supergraph from Hive console's CDN, which is from here. This way, you can leave your supergraph gateway running in a production system and never recompile or restart it in order to get the new supergraph running. I also wanted to show the app deployments, which allow you to publish your persisted documents in Hive console and on requests pull them from console and execute them, as well as insights, which would be showing you usage reporting of operations happening with your gateway without the details of traces, but a good oversight of each of the requests made and the responses as well. Yes? Yes, it will do the composition for you online, but Hive console has checks in place that will make sure that the ending supergraph and the request that you're making to it, combined with your upcoming change to a subgraph, will not break the system. So combined with user reporting and metrics, Hive console can see which fields are in use, as well as subgraphs and all of the details of it. And if you are creating check with that subgraphs changes, Hive console will tell you whether it's safe, meaning no clients out there are using the fields that you are about to change or delete, and will give you a thumbs up whether you can make that change or not. And if it's all okay, and if you approved that change, the supergraph will be automatically composed, and on the next polling interval, your gateway will already have the new supergraph running without restarting anything. Great. No more questions. Thank you guys for attending. You can visit us at the Guild booth, and everything that I haven't had time to showcase, I can showcase you in person. And here are the resources, as well as the link to the repository that I made the commits, so you can actually run all of this that I had locally and see what we've built together. Thank you for attending.